Hey, how's it going, class? Welcome to the first day of geometry. Ironically, we are not even starting with geometry. We are starting with an algebra review. And I mean, if we're getting technical, this is day two, but day one, we kind of just did some brief review stuff that let the schedules even out. So we're doing this algebra review. We're going to cover graphing a line, simplifying expressions, combining like terms, and solving equations. And the reason we're doing this is one, the first unit of geometry, lesson 1.1, has a lot of graphing. So it's really important that you know how to graph. Secondly, we are trying to do placements for next year's math class. So you have kind of three options. We have two listed because they're the main ones that we're pushing. There is transitional, Algebra 2, and Algebra 2 honors. Transitional is kind of a slower paced class. It starts in Algebra 1 material and moves into Algebra 2. Algebra 2 is really technically, it's a college prep class. You don't need to be going to college to take it. I think it's a great class regardless, but it comes in with the assumption that you know how to do Algebra 1. You've mastered Algebra 1 and you are ready to just jump in Algebra 2. Honors does all the same things. Honors is just faster, deeper, and explores the question of why. They are all three amazing classes. I love all of the teachers who are teaching it next year. But the really big thing is where you should be. Where's the best place for you? It is my opinion that Algebra 2, material-wise, is the best math class you'll ever take. I say that having taken a lot of math classes. Algebra 2 is the best. It is life-changing. It will put you in a different position in life if you're willing to take that information, if you're willing to use it. And these three different classes, you're going to cover really similar things. But the key is you need to be in the class that fits you. If you're not, if you're in a class that's either too low or too high, you're not going to get the information you need. If the class is too easy, you're going to sit there, goof off, and you're not going to learn anything. If it's too hard, you're going to hate it. You're going to sit there and goof off and not learn anything. We want you in the right class. So that's our goal. And there's a meme that goes around every year of some old dude talking about how we should drop Algebra 2 because kids need to learn about budgeting and finances and all sorts of other things, taxes. Drop Algebra 2, replace it with a useful class. And frankly, it is one of the things I see on the internet that makes me the most irrational, actually, it's very rationally angry because that is stupidity talking. Algebra 2 is the best math class you will ever take. It is where you learn all of those skills that he lists as being more important than Algebra 2. Because if you don't have Algebra 2, you can't actually understand any of that stuff. You have to have Algebra 2 for any of that to make any sense at all. That in Algebra 2, we start off with the idea of decision making. That we look at different graphs and we look at, okay, we have three things that are dictating what we can do. We have three different functions that describe the reality we want. Well, which one of the solutions do we want? Which one of these maximizes the thing we want? It's a great class. It's how you do business. It's how you make any sort of decision like that. It's an amazing subject. Okay, well, next up, we all throw things at some point. Well, whenever we throw something, that's a quadratic. And how does it move? How does it work? What's happening when you throw that piece of paper into the trash can? How do you know you're going to make it? Well, math can help you. What about when you're sitting there thinking about how you're going to get rich and not have to use any of this stuff that you learned in school? Well, you need to understand what's called an exponential equation. What about when you want to talk about like taxes and stuff? Well, you briefly learn about what is known as a piecewise function, which my recommendation is learn about piecewise functions. They're cool. Don't learn about taxes. Find someone who knows taxes way better than you and pay for it. Because the more you learn about taxes, the more irritated you'll get about it. But you need Algebra 2 to be able to approach any real-world math. Everything up until this point has not been real-world. Is it important? Yes. Do you need it in order to do Algebra 2? Yes. But you're really not there yet. You're not to the point where you're doing real-life problems. You're doing some real-world stuff, but you're not doing it fully. So with that, let's look at some of these skills. So throughout the video, I'm going to say pause the video. You can just give it a pause real quick, do the tasks that I give you, and then continue. For recording the video in my sanity, I'm just going to continue forward. I'm going to say pause, give you 5 seconds to get it paused, and then go. So first things first, go ahead, follow the instructions. So write the following and label. What is M and B? So go ahead, pause the video. So hopefully you remember this. M is your slope. B is the y-intercept. B can also be referenced as the starting point. It's where you start a line. And slope, you might have seen written as rise over run. And yes, I misspelled this intentionally because we're talking about the change in y over the change in x. This little symbol is called a delta. It just means the change in. But when we're looking at this, the idea of slope is if I were to sit here and let's say we have a basketball hoop. And I'm over here. And let's say like me, you're kind of short. Let's say that you're 5'6". Is my concern in any way, or would your concern be, if knowing that you're kind of short, is your concern right now if you have the basketball? Let's get a little orange ball here. Is your concern at all the fact that if I asked you to dunk it, that, oh, I'm too far away from the hoop? No, that's not my first concern. If you said, my life depended on it, you need to dunk a basketball, my concern is not the fact that, oh, I'm in C208 and the nearest basketball hoop is in the gym. That's not my concern. My concern is the fact that I just can't reach. That hoop is too high. And it's the same thing here. We care about the y value first. We care about that change in y first. Then we care about the distance, the x. So keep that in mind as you're doing these graphs. When we're doing slope, we care about the y first. We want to get to the right elevation, then worry about how am I going to make it that far. Stupid example, but maybe it's just stupid enough to stick in your head a little bit. Next up, I want to just briefly look at the different forms of a line. So we've got y equals mx plus b. This is what we call our slope-intercept form. And remember, hopefully from your problem stats class, if you had me, we always talked about what are mathematicians? Mathematicians are lazy. We want to do things the easiest way possible. We don't want to put a lot of work into something if we don't have to. We're not going to put a lot of work into naming something if we don't have to. Slope-intercept form is awesome because it tells us the slope and the y-intercept. It's useful. It's straightforward. There's no like, oh, it's the Bernoulli principle. Nope. Straightforward. Slope-intercept. You get the slope, you get the intercept. There are a couple more forms of a line that you might see. I'm going to go over the most common ones and kind of tell you where they're useful. The next one that's kind of useful is this one here, y minus y1 equals m times x minus x1. This is what we call point slope form. I want you to take a second, pause the video briefly, and ask yourself, what do you think point slope tells you? Well, you would be right if you had said that it tells you a point on that line and the slope. No tricks here. We try to be straightforward here in math class. The last one is one that looks like this: ax plus by equals c. And this is what we call the standard form. And I'm going to be really honest with you. Standard form is the most useless without a computer. Like, you can do things with it. Standard form does have its uses, but a lot of its uses come in how do I use a computer to look at 100 different equations all at once. That is where standard form is super useful. For us, for the most part, what we're always going to do, we're going to take standard form, and really we're going to take point slope as well. We're going to take both of these and turn it into y-intercept, or the slope-intercept form. That is always, like, our default is going to be graphing from here. But I wanted you to see this. I wanted to point it out because if you see one, you should be able to identify it. And why that's important, let me find a good color that pops, is anything that has a exponent of 1 on the x and the y, but primarily that x, that's a line. Lines have, eraser, lines have x to the first. So keep that in mind as you're looking at things in this class. But let's take a look at graphing them. So when we're graphing these things, we always kind of want to default to, well, maybe first, before we even start graphing, is what is this doing? This is a function. And functions are just commands. Functions are a list of instructions telling you to do something. If I told you to stand up, spin in a circle 10 times, and walk outside. This is a function on you. And for each one of you, whoever's watching this, you're all going to do something slightly different. Some people are going to spin really fast. Some people are going to ignore the spinning and do nothing, and they're just going to keep watching this video. Some people are going to stand up and walk outside, and they're going to be outside of the school. Some people are going to stand up and walk and be outside of their house. Or some people are just going to walk out of the room and walk back in because I'm still talking to them. It's going to be different. You, as the individual, matter, and how you interact with what I said is what's going to make the difference here. That is all a function is doing. This function, y equals 2/3 x plus 1, this is taking and saying, pick a number, multiply by 2, divide by 3, and add 1. That's all it's doing. It's just a series of commands. Now let's think about, we've got PEMDAS here. And I write these this way so that they are equivalent, because multiplication and division are the same thing. One just undoes the other. So as you're looking at this, as you're working through it, I can switch these two. I can switch multiplying by 2 and dividing by 3. And I'm going to do that because whenever we're doing a graph, it's helpful to make a little XY table. And the reason I want to switch that is because if I think about dividing by 3, if I choose multiples of So multiples of the denominator for x values. It's going to make my life way easier. That if I choose multiples of that value, so dividing by 3, got a 3 in the denominator, so I'm going to go 3, 6, -3, -6. So when I plug these in, it's going to make the denominator go away because I'm going to guarantee all of you hate working with fractions. If you're smart, you can get around working with fractions. If you use your brain for 10 seconds, you can get around it. So we're going to take and just plug in these x values. So 2/3 times 0 plus 1 is, well, that goes away because anything times 0 is 0, and I get 1. I'm just going to plug in these values. 2/3 times 3 plus 1, well, those 3's cancel, and I get 1. And 2 times 1 is 2, plus 1 is 3. And I can just keep doing this. And it's really good practice. I would write out all of this stuff as you're first using it. Those cancel. I get 2 times 2 is 4, plus 1 is 5. 2/3 times -3 plus 1. The 3's cancel, but the negative doesn't. So I get -2 plus 1 is -1. 2/3 times -6 plus 1. The 3's cancel, but I'm left with a 2. So I get -4 plus 1 is -3. And we're doing this kind of graphing because this is what you're going to be doing in Algebra 2, but it's very foolproof. Like, just plug the values in, get 5 of them, and start graphing. So I get the point 0, 1. I get 3, 3. 6, 5. -3, -1. And -6, -3. We like 5 points because when we graph 5 points like this, it's going to show us that it is, in fact, a line. Now, you'll see sometimes your pictures aren't great. One thing you can do, go back in, just make your dots a little bigger, and hit those points. These are sketches. These are not meant to be perfect. If we want it perfect, we've got computers that can do that. We want you showing this equation as a visual. So if you need help with this, make sure, come in, talk to your teacher, talk to me, talk to Miss Gelsinger if you have her, and get help because we will gladly help you with this. But feel free, you can just follow along with the video, see if you can pick up a few of the tricks. So here, same thing, I'm just plugging in values. X, Y, 0, and I'm going to choose multiples of the denominator. 4, 8, -4, -8. And I'm just plugging in those values. 4 cancels, I get 3 minus 2 is 1. Plug in the 8, I get 3 over 4 times 8 minus 2. Well, the 8 cancels, I'm left with 2. I get 6 minus 2 is 4. And you're going to get way faster at this. You're going to just get smooth at doing it, but it takes practice. 3/4 times -8 minus 2 becomes 3 times -2 minus 2. -6 minus 2, get -8. And just, it's practice. That's it. If you need more practice, feel free. You can stop by and talk to me. I have a bunch of practice problems of this on an app called Delta Math that you can do. I have many of them set up so that you can just pretty instantly get more practice. Let's see, so we get our line through it. And it's not bad. We've got all of our stuff here. So go ahead. I'm going to continue through, pause the video, graph the line, and check it against the answers. So you pause the video, try this one out. But as you're working through it, hopefully you're maybe starting to see that, hey, well, there's some easier tricks. There's some ways I can do this to where I don't have to rely on the table. Where maybe you are figuring out that you can make the table second. And you can just go through and make it really fast. Ideally, you should spend less than 30 seconds on each of these problems. So go ahead, pause the video, give this one a shot as well. And same thing, 1, 2, 3, 4, 5. 3 over 1, up 3 over 1, down 3 over 1. I'm going to go this way more just to get my points without having to draw more on the graph. And just as you're graphing this, you're going to get better. It just takes time, and you have to trust the process. All right, go ahead, pause it, and graph these two. Now, I like to think of x as my choice and y as my consequence. And when I'm looking at this thing, I have choices and consequences all the time. X is my choice. This is saying, no matter what, I'm doing the same thing. Which maybe you've met some of these people. This would be principle. No matter what, I go to 5, 1, 2, 3, 4, 5. It doesn't matter what the outcome is. I'm going to do the same thing regardless. Or maybe it's not being of good character. Maybe this is a bad thing. Maybe it's like, no matter what, I'm going to do the wrong thing. That's an option. I say it's a positive choice since it's a positive value. But this would be x equals 5. No matter what the outcome, I'm going to do the same thing. Then let me switch colors here for y equals 3. So y equals 3 is then the opposite. It is, no matter what you do, the consequence is the same. Like, regardless of what you do, it's always going to go exactly the same. This might be your fate. This is no matter what, it ends the same. So hopefully this helped. Hopefully this is making a little bit of sense. If it's not, please come in and talk to your teacher. We want to help you, but we cannot help you. We cannot help unless you ask. We love helping you. We want you to get this. We want this to make sense, but you need to tell us. Have a great day. I will see you in the next video. Hopefully I'll see you in class.